Hello and welcome to this session of SmartStream for using observational AI to enhance data quality. My name is Stephan Dietrich and I am an AI expert and senior data scientist at SmartStream. The company SmartStream has over 40 years of experience today, and 70 of the world's top 100 banks, capital markets, and buy-side firms and collaborations rely on our technology. How great is that? Here in the SmartStream Innovation Lab in Vienna, where we are a collaboration of highly skilled mathematicians, applied data scientists, and IT specialists, we are creating new and exciting developments within the machine learning and blockchain technologies, which we are then bringing back to our big customer base of SmartStream. As I said, we are based in Vienna. At the moment, we have 12 exciting AI projects in the making or already in production. We are doing stuff within the data enrichment so data inflow kind of AI tasks. We are preparing data and increasing the data quality with AI technologies. And we especially are focused on workflow optimizations to reduce manual interaction points. We are using state-of-the-art machine learning and deep learning in technologies, and we are also developing some of our models on our own. So, observational learning. How do we learn best? This is a question that I think every kid asks itself when it has to tie his shoes and it's watching her mother or father to how to do this, right? And it's very interesting. How do kids do this? They observe. They try to, from observations, they try to decide how to do what the grown-ups are doing. But we are no different. Also, when we want to learn some new stuff like cooking a delicious Italian dish or so, we are also just going on YouTube and searching for a video, right? So we also observe and imitate then a chef doing a great deal. So the key concepts of observational learning are, of course, observing, learning and retaining, then trying to imitating it, and for us all then to benefit from it, right? A key concept for AI in finance is if you have such kind of AI models that you want the model to be very confident. That's kind of the key. And for this, you have to really ask yourself, or you as data scientists have to ask yourself lots of questions. Namely, how many examples or steps does a certain machine learning model require to get confident? Which features from the many to choose from should you use? Which architectures fit the domain in this specific financial topic area the best? Right? And what are the relevant time frames to be considered? Do we have to train for 1 year? Do we have to train for 1 month? So this might be rather technical, but it's very interesting and very important that you can rely on the model if it's confident, that you can rely that the prediction it is doing are also confident and high probability predictions. Why is this important? Because if the model is confident, you can automate workflows very easily. So if the machine learning model is very confident, you can derive automatic actions from it. If it's just confident, you can still generate suggested actions and let a user or the users decide if they want to do them or not. Or the model tells you, hey, I'm not very confident, so either no actions are performed and it's still up to manual, or we have to work on the model more. Another very important topic within finance is that you have an explainable AI. As we have talked last year, there's always difference if you are using a white box AI versus a black box AI. And of course, a white box AI is the financial regulator's preferred approach because there's no hidden mystery about the AI decisions and you have full transparencies into why the AI came up with something it did. Very important to trace this is that the AI has explainability built within so that the AI actions are explainable. Because you need to know, why did the machine learning model decide on this? And on which inputs did it base its decisions? This is mission critical to have in a kind of audit log to control the decisions and to log the decisions, especially for financial regulators. So let's do a use case together. We have a problem statement, namely, we want to reconcile transactions considering several data feeds. It's a big data problem, so we have millions of transactions. We have complex patterns and rule fuzziness of the references that are embedded in those transactions, and it's really a tedious work and a huge manual interaction necessary to do those things in a traditional way. So the solution is to use an observational AI to learn and apply these observed actions from the users that have done it before. This is way more sophisticated than RPAs, and it provides huge cost savings to the customer. Affinity AI. Affinity observes user actions and learns from them. Once it's trained, it automates the actions or provides suggestions to the users that are using it. And with each training, the component provides a confidence of the machine learning model. So you always know how confident is the model, as we have discussed before. And with each suggested group, the component also provides a probability and an explanation for what or why it has done something. And affinity can be used in several ways. You can use it in a batch, so overnight, next morning, users get auto suggestions or auto matches. Or if you have something that you can train on while the user is doing it, so this is kind of online learning, this is then the ad hoc integration of affinity. So let me show you how, after you have matched records, how affinity is explaining itself, right? So let's do an example together of Affinity AI. Affinity AI, as you can see here, which is totally integrated within SmartStream Air, our cloud-native platform, is that we have matched 2 records already, and the AI model tells us it is 96% confident that it can produce now a suggestion on its own. We have produced here several suggestions where the AI matched records from 2 feeds together. But now we want to know why it did this. And in the following video, we visualize how the AI explained itself. This example you can see now, we are highlighting with Affinity AI the explanations that have driven the AI to match those records together. So after we have now seen Affinity perform, the question is, what kind of benefits can we get from this? So visualizing here, we have had a POC with a Tier 1 bank, which had a complex reconciliation, and those are the statistics they had before. So they had 35% auto-matched, 3.3% suggested, but 44% of the work was manual. And 17% they could not match because it would have been matched on one of the coming days. So what we have done with Affinity AI is we have provided the AI the manual matches and the unmatched from 1 month's time from the client and have trained Affinity on this. So what have we achieved with Affinity AI? From the outstanding manual or unmatched data that we were presented with in this POC, we have matched 61% automatically. We had only a minor missed rate of 0.66%, and we had left 38% unmatched. If you compare this to the remaining manual work that has been necessary then for users to do manually, you have to see this little pie diagram here in the middle. The rest anyhow will have been matched on the following days. This meaning that we have, with Affinity AI, provided to the already in place auto and suggested matches, we have taken 61% of the manual work from the users and have only left little to do. As said, here in SmartStream, our technology and our advantage is that we have the most advanced AI solutions for financial services. We make it easy to control, we make it easy to do cost reductions, and we make it easy to have efficiency gains within your company. If you have questions or anything that you want to ask us, please do so. We are happy. And if you are interested in our solutions, you can always check out our SmartStream website, smartstream-sdp.com. Thank you, and let's go on.